Welcome everybody to the 7th lecture of Informatik 1. Today we will continue with the second part of data analysis. In the previous lecture we already looked at the first 3 steps in the data analysis pipeline, the first being the data extraction, and in this step we used the CSV package to read CSV files, or we also used the pandas package to directly read in CSV files in a so-called data frame. The next step, we had the data cleaning step in the pipeline. There we also used, for example, the pandas package and the log operator to filter out certain rows in a given data frame. And in the last part of the previous lecture, we use the NumPy functionality inside the pandas library to perform various calculations on the data. And in today's lecture, we will focus on data visualization using the matplotlib library in Python. So why do we need data visualization? As the name already suggests, because it is a visual representation of data. And data is often easier to understand visually. Further, it also supports your written arguments. And it is easier to extract patterns out of the visual representation instead of looking at raw numbers. Further, as a quote says, a picture is worth 1,000 words. So, how does the basic procedure of data visualization look like? So first, we need to get from the raw data to the processed data. And to do so, we need to perform the first 3 steps in our data analysis pipeline, namely filtering, cleaning, anonymizing, and transforming our data. And after that, we can continue with the second step, which is choosing a visualization type. For example, a line chart, a bar chart, a pie chart, or a heat map, and so on. Third, we need to open the documentation for the visualization type and read it or hit a Google query. And then we can create our first visualization and then continue with the adjustment of the style. And as a last step, we can check if the visualization supports the intended proposition. So how does the visualization in Python work? Unfortunately, Python has no native visualization tools. Therefore, we need to rely on external packages which fill that need. And there are different packages out there. For example, the Bokeh library, which produces plots for the web in HTML format, for example. Or there is also matplotlib, which is more suited if you want to produce plots which are printable, for example, in a report or something like that. So in this lecture today, we will cover matplotlib. We can import matplotlib using the from import as notation. So from matplotlib, we want to import pyplot, which is a specific Python interface, which is MATLAB-like. And we want to import it as PLT. So we can access it by writing PLT. And the similar notation, as we already know it, is just the simple import, import as. So we just type import matplotlib.pyplot as PLT. So yeah, you can use one of these 2 methods. They are both the same. Yeah, it's just another way of writing it. So matplotlib is, or this pyplot package. This is the main package for plotting, and as already said previously, matplotlib is mostly used if you want to produce plots which you print out basically, or use in a PDF file, for example, and you can generate raster graphics out of it, which are the typical JPEG or PNG extensions. And you can also produce, more importantly, vector graphics, for example, with the PDF extension. And yeah, Matplotlib is widespread and has a great support out there. It is quite easy to use, and it has some really nice extensions. For example, the Seaborn library, which supports additional plot types. So there are basically two base objects in Matplotlib. The first one is the figure and the second one is the axis. And you can get those two objects by calling the subplots function inside the biplot. And yeah, as you can see, subplots returns a tuple basically. The first element being the figure and the second element being the axis. And yeah, using this notation, we can store the tuple in two separate variables, the first being the figure, the second being the axis. And the figure object is a container object for the whole visualization, and it therefore can contain multiple axes, which can share, for example, the x or y axis. And the axis object contains a single plot. So for example, a line chart, a bar chart, and so on. And you can then save the whole plot, so the whole figure, using the figure object and not the axis object. So you can type, for example, figure.savefig. So you need to call the savefig method. All right, so that's the difference between those two objects. So the figure object contains the whole visualization. So for example, you can have multiple plots in one figure. And yeah, if you want to store the whole figure, you need to call savefig on the figure object. So the first steps, again, we need to create our figure and axis object using the subplots function. Then we can generate some data, for example, using the NumPy package. And then we can call the plot function on our axis object, which contains the plot, and provide the data. And plot is generally a line plot. And then using the show function, we can show the plot, and this will produce the following plot. So as you can see, the data is just a simple sine from 0 to 200. So we now know how we can produce a simple plot in Matplotlib in Python. However, the previous plot didn't have any axes and labels. And since charts without labels are useless, one does not simply create charts without labels. And therefore, each axis object can be labeled on y and x axis. And therefore, you can use those two functions. So using the axis object, you can call the set_x label method and the set_y label method. And yeah, those two methods do exactly what you would expect. So they set the x and y labels. And yeah, you can pass the method a string, which is then your x axis and y axis label. And those methods also support mathematical symbols. So for those of you who are familiar with the LaTeX encoding, you can use the LaTeX encoding here. So for example, by using the math mode in LaTeX, indicated by those two dollar signs. So for example, by typing $\by$, this encodes in LaTeX pi symbol. So you can use this LaTeX encoding in Matplotlib. So then let's move on to markers. So markers are defined in the axis.plot call, and those markers mark each single value in a line plot, for example, and this helps to distinguish between multiple lines. So for example, if you produce a black and white plot, since you are printing it out, for example, only in black and white, a really helpful way to distinguish two multiple lines the same color is using different markers for each line. And there are many different markers available, so you can check out the Matplotlib documentation there. And yeah, as stated in the first sentence here, the markers are defined in the axis.plot method call. So in the plot function, the first two arguments are basically the x and y values, and then you have multiple arguments for the marker. So using the marker keyword argument, you can set the marker symbol, you can set the marker size, you can set edge color and the face color for the marker. So the edge color is basically the color of the outline, so the border color, and the face color is the inner color, the fill color of the marker. We will see an example later then how this looks like. So then what is also very important if you produce plots are legends. So give each plot a name and a description. And again, you can set a label for the plot inside the plot method using the label keyword argument, and then you can pass a label or a description as a string, and this shows line type and name, and the correct placement is important, so you shouldn't cover any lines or bars, etc. And in most cases, Matplotlib handles this automatically for you. And yeah, if you want to include the legend in your plot, you need to do this in the axis object, obviously, because each plot can have a separate legend. So if you want to include the legend in a plot, you need to call the legend method. All right, so how can we then, for example, produce multiple plots on one axis? So each call of the axis.plot creates a new plot. And it is very important if you produce multiple plots on one axis, or for example, multiple lines on one axis. If we use a line plot, for example, use colors, markers, and legends. So this is very, very important. Here you see a very, very bad example. So here we have two plots or two lines in one axis, basically, one plot. And yeah, you can see both those lines are black, so you can't really distinguish between those two lines, especially where the lines cross. You don't know you don't know where the line continues, basically, where which line continues. And you also have no axis labels, you do not have a legend, and so on. So a better way would be the right plot. So as you can see here, you have axis labels. So on the y-axis, you see this plot shows the alcohol level in per mil, and the x-axis shows the days after your graduation. We also have a legend at the left side on the top, describing what each of the line represents. So you can see here the blue line using the triangle as a marker shows the alcohol level of Max Muster student after, or as a time series of the days after his graduation. And the orange line with the circle markers shows the alcohol level of Max's best friend forever. Yeah. And as a side note, I don't want you to encourage to drink alcohol. So yeah, this is just for learning purpose. All right. So on the left hand side, you see a bad plot without any legends, axis labels, different line colors, and so on. And on the right hand side, you see a good plot, where the information is clearly visualized. All right, so if we have then produced such a nice plot, we can use the save fig method to save the whole figure. And yeah, inside the function or inside the method, we need to define where we want to save our figure on our computer, and therefore we need to specify a path and an extension. So yeah, as already said, always use the figure object to save a plot, and the file type of the plot is determined by the file name plus the extension. So you can usually use, for example, the .png or .pdf extension. Yeah, PNGs are faster because those are raster graphics. However, PDFs have a higher quality because those are vector graphics. And I'll show you a small example later where you can see the difference between those two file types. So here you can see some further chart types. So yeah, the first one is a histogram, which basically shows the distribution. In the middle you see a scatter plot. On the right hand side you see a bar chart, and yeah, at the bottom you see the links to the documentation if you want to dive a little bit deeper into those chart types. All right, let's look at the examples. So first, as always, we need to import our library. In this case, we would like to import the pyplot interface from the matplotlib library, and we want to access this functionality as plt, as plot. And second, we also import numpy because we use that a lot in general. So we execute this cell, and then we create our matplotlib objects, namely the figure and the axis object, which is returned by the subplots method. And then we define two lists basically. The first list represents all the y values, just being a list of floating point numbers, and the second variable here holds all the x values, and in this case I use the arrange function from numpy to create a range of integers from 0 to the length of my list containing all the y values. So those two lists have exactly the same length. And then, as already said, using the axis object, I can plot my numbers, and the first argument is the x value, and the second argument are the y values. So yeah, the first argument is always x and the second is always y in case of positional arguments. And then we can show the whole figure using the show function. So we call plot show, and then if we execute this, you see the plot gets displayed directly in our Jupyter notebook. All right, and then since I told you that subplots returns a tuple, and in this case we directly stored each element of the tuple in a separate variable, we can check this if this is true if we just, for example, store the result of this function call in a single variable called figure and axis, and we then print out the type of this variable and also the element itself or the value of the variable, and at the end we close the our plot again. because matplotlib, if it's used in an interactive environment like the Jupyter notebook, then matplotlib automatically displays the plot. And if you don't want to show up, if you don't want that an empty plot shows up, we need to close it. So yeah, let's see. If we execute this line, you see that the value inside this variable is indeed a tuple. And if we print it out, you can see it is a tuple because of the round brackets here. And the first element inside the tuple is our figure object with this size here in pixels. And the second object here is the access object, a matplotlib access object. Yes. And you see, for example, if I remove the last piece of code here, the close, then matplotlib shows, in this case in the Jupyter Lab, an empty plot. And if we don't want this, we need to close it before the end of the cell. All right, then we can add a second plot to the figure with a second call to the plot function. So each call to a plot function adds a new plot to the same figure. And so again, we call the subplots function, and we then specify using keyword arguments the number of rows which the figure should have and the number of columns which the figure should have. In this case, we want the figure to have 1 row and 2 columns. And again, we define our x and y values. And as you see here, since I have my figure in total has 2 plots on it, we also get 2 axes here, right? And on the first axis, on the first plot, so to say, we want this plot, and on the second figure, so to say, or on the second plot, on the second axis, we plot the same values, however reversed. So let's look what happens. So as you can see here, we have 1 row as defined here and 2 columns as defined here, and therefore we have in total 2 axes, namely 1 and 2, and therefore we can store these directly in variables using this notation here, axis 1 and axis 2. And then here I plot the normal xy values on the first plot here using axis 1, and using the axis 2 object I plot the reversed values on the second plot here, as you can see. You see this is the inversed data, as you can see. All right, that's it for that. Then let's take a look how we can change the size of the figure, because you see here it's kind of small. So to increase the size of the figure, or to change the size of the figure, we can use the fig size argument in the subplots call. So again, it's just the same code as previously. However, we define a figure size, and the figure size argument takes a tuple, where the first value in the tuple is the width of the figure, and the second value of the tuple is the height, and the numbers are represented in inches. So it's 10 inches wide and 5 inches height. So let's look. It should be bigger now, and as you can see, the plot is now bigger and wider, not so squeezed in as here. All right. Then we can add labels to the plot using the set x and set y label method, and again we need to call it on the plot where we want to set the label. In this case we only create one plot in the figure, therefore we only have one axis, and again we just print out our x and y values as always. And then on the x label, this is again, for example, the days after our graduation, and on the y label we have alcohol level in per mil. Again we plot it, and you now see that we have added the labels here, the axis labels. Yeah, that's that. Then let's move on to the markers. Again we create our same plot, pass in our x and y values, and then using the marker keyword argument we can set the marker sign. In this case we want the circle as a marker, therefore we need to specify the O as a string, which represents a circle as a marker, and we want the size of the marker should be 8. I think it's in pixels. And then we can define also a edge color, so the border of the circle should be black and the face color should be orange. So let's see how this looks. So you can see, okay, we have added those markers here at all the points, at our data points, and the face color is orange, so it's inside it is orange, and the circle outside the border is black. And yeah, that's it for that. And we can also, for example, change the marker sign. So if we, for example, make an X here, we get a cross as marker sign, or we can make this strange, I don't know what's the English name, cap, the cap sign. This should then be a triangle. Yeah, and there are many different markers out there. Just look up the documentation of Matplotlib for further markers. All right, then let's move on to adding a legend. So yeah, a legend makes sense if we have, for example, multiple lines on our plot. Yeah, we can add a legend using the legend method. So yeah, that's that. And if we need to make a description for the plot, so if we call the plot method, we can define as a keyword argument the label. So this plot, this line, what we plot here with these x and y values should have the label Max Mustermann. And only if we also call the legend method, then the legend is shown in the plot. As you can see here, if we scroll down, the label got added at the bottom left of the plot. And yeah, this makes more sense, or even more sense, if we have multiple lines on our plot. So each call to plot on the same axis object adds a new line in this case, since we have a line plot here. So again, we create our figure and axis object, define our y and x values. Then in the first call to the plot function, to the plot method, we say the first line should be labeled as Max Mustermann, or the first line represents data of Max Muster student. And the second call, in the second call to the plot function on the same axis object, we add data for Max BFF. And yeah, here, as you can see, I directly specify the y values in the call to the plot function here. Yeah, you shouldn't do that. It's just here for for learning purposes. But that's not a nice way of passing data to a function. Yeah. So you should do something like this. Y of max BFF is this. It's nicer. Whoops. And then define it here. Max BFF. All right. And as you can see here, I specified the label here. As you can see, the new orange line got plotted here, which is the data of max BFF. And yeah, here we use the marker as a circle, and yeah, defined the marker edge color and also a marker size of 10. Yeah, you can play around with this. And only if you call axis.legend, then the legend here will be added. So for example, if we comment this out, you see that there is no legend, although we have defined the labels here. All right, so you always need to call legend. All right, and then last but not least, we eventually want to save the plot also on our hard drive. And in order to save the plots, we need to call the save fig method on the figure object. So in this case, since we want to save the whole figure and not only a single plot, yeah, we need to call this on the figure object. And yeah, as already said in the slides previously, define, or depending on which extension you define here, also the file type is determined. So yeah, in this case, I store the figure or the plot 2 times. One time, or the first time, in PNG format, so this is a raster graphic, and the second time as a PDF, and the PDF is a vector graphic. And yeah, I name the files highly scientific chart, although they are not very scientific. And yeah, let's look if it works. So here I refresh my contents here, and as you can see, the 2 files got created just a second ago. And then yeah, let's open both of them. So this is the PDF file, and you can see it's crispy clear here. And if I open the PNG file, you see it's a little bit smaller. And yeah, if I zoom in, you see it doesn't get sharp. So yeah, it's not that nice. And if I do the same at the PDF file, you see if I zoom in here, the quality gets nice. So this is because it is a vector graphic, and yeah, it has always a nice quality if you zoom in, for example. All right, that's it for today's lecture. And as always, thank you for your attention, and see you next time.